In this problem, we're going to prove the mean value theorem for integrals. So this is a nice and beautiful formula that's helpful in solving some theoretical problems. We don't pay a lot of attention to it, but it's very useful when we are dealing with some kind of integrals. We're also going to give some geometric explanation or interpretation. And I'm going to tell you what my ex-professor used to tell me about this one in particular. Okay, let's prove this one. So to prove this one here, we're going to use the mean value theorem for derivatives. Okay, to do that, we're going to define a, let's call it f of x as being the integral between a and x of f of t dt. F is continuous. In this case, this is our condition, and x is in this interval a, b. In this case, our function is continuous, differentiable on this interval a, b. Therefore, there exists some c such that c being in this interval AB, the open interval AB, such that f prime of c is equal to f of b minus f of a over b minus a. F of b is the integral between a and x, a and b of f of t dt, and f of a is 0. Therefore, and using the fundamental theorem of calculus, f prime of c is just if we differentiate f, we're gonna have f of c. Okay, because you remember, f prime of c is just gonna be f of c, because f prime of x is just gonna f of x, the small f of x. So the derivative of the big F is the small f, and using that here, we see that f prime of c is just f of c, and using these values, f of b minus f of a, which is 0, we get f of b over b minus a. And f of b is just the integral between a and b of f of t dt over b minus a. We can rewrite this one in a simpler form as the integral of f of t between a and b as f of c times b minus a, with the c being in AB. Okay, so the integral here between a and b can be written as the value of f at some c times b minus a. Okay, so this one can be, geometrically speaking, if you think of your AB as being this interval. Okay, this is my area, the integral between a and b f of t dt. Okay, there is some value c here in this interval that this area can be made similar to a rectangle. Okay, some c. So in this case, the area here is going to be b minus a, which is the width of this rectangle, times the height, which is f of c. Okay, so my professor used to like cakes in forms of rectangles, and his wife used to make cakes like this. He told her one day, instead of making cakes of this form, find a point C and you can start making cakes like this. The same cake, but the different shapes. We're going to see some applications of this one in the next few videos. If you have any comments or questions, please comment. If you don't like the video, hate it, as you like. If you like it, share, subscribe, and have a great day.